The Digital Equipment Computer User Society presents this live recording from the 1985 Spring DECUS U.S. Symposium, held May 27th through the 31st. We take you to New Orleans, Louisiana, where the program is just now beginning. The following material is for informational purposes only, and is subject to change without notice. Neither DEC, the author, nor DECUS assume any responsibility for the material, its use, or applications.
Rocky Selwinski from the PC Personal Computer Stage, which is sponsoring this session entitled Introduction to Rainbow CPM and MS-DOS. With us today are three members of the Rainbow Development Group: Marshall Goldberg, who is the Principal Engineer and will be speaking on MS-DOS; Bruce Gibson, and he is the Lead System Support Engineer and will be speaking on the CPM side, and with him on that is Rain Letter, who is the project leader for the firmware. We're going to ask that you note your questions during the session, and we'll have time for some Q&A if it permits. And with that, Marshall?
Okay. I'm going to introduce MS-DOS. Let me take note that I have another session after this one on MS-DOS that's going to last an hour and a half. I'll be going over many of the same slides, but I'll be taking a lot more time to do so and stopping for questions and answers. So if you have questions and answers to MS-DOS and want a more detailed explanation, please come to the next session. Okay, now these slides, some of them will say version 2.05. The currently released version of MS-DOS is 2.11. Any slide that says 2.05, the same information applies to 2.11. Our current MS-DOS runs generic 16-bit MS-DOS applications, formats floppy disks, and it contains an online editor, assembler, and debugger. Digital bundles the assembler with the operating system disk. By generic 16-bit applications, we mean such products as languages, Microsoft languages, for example, including MBasic, a generic MS-DOS product. Our current versions of MS-DOS support the hard disk. It will read and write Rainbow disks and will read IBM 8 and 9 sector disks. There's a caveat there. If you write an IBM 8 or 9 sector single-sided disk on a Rainbow, you can't read it on the IBM. And of course, our current version of MS-DOS, version 2.11, is compatible with previous versions. Another overview, support for the Winchester hard disk. We have yet another improved RX50 driver in MS-DOS 2.11. You can create a RAM disk up to 832 KB for improved performance. Of course, it isn't saved when you shut off the machine, so be careful if you use it. And we have superb new communications and printer drivers that are part of MS-DOS. And this is a difference between our MS-DOS and some of the other brands' versions of MS-DOS on the market. And also a print spooler, which is a neat feature because what you can do is have your application send all its output to a file, then start the file printing and do something else. It will run in the background. It will queue up to 10 files. This is another overview. We have a read CPM utility. Of course, Lotus 123 is available. Lotus Symphony is available. You can hard format diskettes with our MS-DOS. And we have a new backup restore utility. This applies to version 2.11, which is our timely update. We have a number of new features, improved access to the communications drivers, much improved international capabilities, and of course we've corrected known bugs. We also have we have support for the Mini Exchange, which fits on the serial line and permits a Rainbow to share printers and modems. I spoke to a chap yesterday that was using Mini Exchanges to do almost network-like type applications, where he was at a school and wanted one central facility to hold files so all the students wouldn't have disks. We also include the setport utility now for setting all the parameters, and it's quite easy to use. It's a nice utility. 8-bit character support, international character generation, and an improved sort utility, which is part of the base operating system. It easily incorporates commercial metrics for 99 countries, metrics for France, Germany, Israel, Italy, Japan, Portugal, Spain, and the UK. It's very important to digital because we have very large international markets. Okay, here are some of the basic commands. Now this, once again, if you have any questions or you're confused by the rapidity with which I have to go over this section of the presentation, come to the next presentation. I'll answer questions as things go along. A basic command is a directory to find out what files are contained on your currently selected subdirectory. And there are some examples. Just plain durable, display all the files in your current default subdirectory. You can also do a directory of other devices, be they hard drives or diskettes. You can do selective directories, and it will display the file size, and the time and date stamp. Okay, there's the type command, which will display the contents of a file. Now you'll notice the word path in there. Path refers to subdirectories, which are explained in more detail later on. But it's a way to specify a path to a file and logically organize a disk. And it's very important to users to understand the capabilities of subdirectories. It allows you to organize your diskettes or your hard drives when you have hundreds and hundreds of files without getting lost. And there are two examples of type. The copy command in MS-DOS is very natural. It's copy file spec 1 to file spec 2. Once again, path can be specified, path being a path to a subdirectory. You can also append to files. You can append them as binary files or ASCII files. You also can see the third example, copy con to quick bay. That's an example of quickly creating a file at your MS-DOS keyboard. Let's say you want to just create a quick batch file to do a particular job for yourself and don't feel like coughing up an editor. You can do copy con to file name and just enter the text and end the file with a Control-Z. And you can quickly create a file that way. Rename command, that's pretty apparent what it does. Article text to article old. You can also do wildcard renames, which is a nice capability. The print command. The nice thing about MS-DOS is it contains a print spooler which will print in the background while you're doing other things. And there are switches on the print command that let you stop the current file, let you cancel the current print queue, and if you're in the process of printing files and just do print with no parameters, you'll get a return of the status. It'll list the print queue to you and how it's proceeding. That could be useful if you have a printer in the next office, or you just want to know what has to be printed. You also have your date and time commands. Those are optional, but I strongly recommend if you do any development at all on your machine, you always set the date and time. The reason why is it lets you rapidly tell from a directory command what the date and time that you created the file is. It's a very good capability. It's something that CP/M lacks that MS-DOS has, so it should be used. Check disk. A check disk is a special utility that comes with MS-DOS that checks, it checks the directory only of the disk. It will check any disk, a hard disk, a diskette. Sometimes if you have a file open and something happens, your machine crashes because you have a bad program, it will leave lost clusters. If you use check disk/F, you can recover those clusters, delete them, and you'll recover the space on your disk. It's a good warning, too, because sometimes when hard drives fail, you'll see funny things happening in the directory. So if you're running MS-DOS, use check disk once in a while, maybe twice a week, or after something funny has happened with the machine, just to see whether the directory is doing well. It also blanks out previously deleted files in the directory, too, so it cleans it up. Disk copy. Disk copy is an external command. It's a utility, and it duplicates the entire disk. Our disk copy requires that you previously have formatted the diskette, and you can hard format diskettes with MS-DOS. File compare, once again, it's a useful utility for developers. You can compare two files. There are a whole series of switches, well documented in the manual, so I won't go into them here. The format command prepares a diskette for use or a partition on a hard drive. There are two switches with the format command. Format/S will put the MS-DOS system files. There are three system files: the command processor, the I/O system, and the actual MS-DOS system. It will put them on the disk. /I, which does the actual hard format. So you're using an outside vendor's diskettes that aren't pre-formatted, or you have digital diskette and the format has failed, you can do a format/I, and it will give you a hard format. It's a good utility. Sorry for the misspelling there. Here's a useful, this is a more advanced command, CTTY, of particular use to developers because it lets you change the command console to a terminal. CTTY aux is the most common that we developers use. And it's a neat way of running, you can run the debugger through CTTY aux. Then if you have a program that directly accesses the screen, you can still run the debugger. It's very useful to developers. Media check will potentially speed up diskette accesses, but due to improvements in MS-DOS, it's really quite optional. It really doesn't matter too much whether you use it or not. If you have media check off, you can't read single-sided IBM diskettes. So you'll see the utility there, but it's really quite optional. So for historic reasons, we actually still have it. Now, path is a useful command. Very useful to the average user because path tells the command processor, command com, where to search for an executable command. And a path can be quite long. And the command processor will always search in the following order. First, it will search the default drive for the command that you typed. Then it will follow the path command in order. Path with no parameters will display the current path. Now these paths are in the form of subdirectories, which we're about to explain. But you can see the first white path first will search the root directory, then it will search subdirectory user, subdirectory Joe, then it will search drive B. The only caveat in specifying a path is if you have diskettes and let's say you've specified path B : then you leave the diskette out of the drive, it's going to hang and will say retry, ignore, because it will try to access the diskette. So if you specify a diskette drive in a path, it's a good idea to have a diskette in the drive. Prompt is another advanced MS-DOS command. Prompt lets you actually change the MS-DOS prompt, and there are some very interesting things I've seen done with the MS-DOS prompt command that make the MS-DOS actually look like a menu, a command menu. And there are special characters that you can put when you specify a prompt which will give you different results. Like $G gives you the greater than symbol, $N gives you the current default drive, $P gives you the current defined default subdirectory. Prompts can be put in an auto-exec bat file, so when the system first comes up, you get the prompt that you like. You can have escape sequences in a prompt too, so if you want to have the date and time displayed, if you want to have the date and time displayed in the upper right-hand corner of the screen, they're all relatively easy. It's a nice command. I go for the second form of prompt myself, the $P, $G, because I always want to know what subdirectory I'm in. When you have a lot of subdirectories, it's easy to get lost unless you have that display. So it's nice to have it. Verify on-off is a very simple switch. Normally when MS-DOS does writes, it does not read after it does the write, just for reasons of speed. But from time to time you may want to have it verify all writes. You can do that globally by doing verify on. If you do verify on, every time the operating system does a write, it does a read to verify the operation is correct. You can do it on a transit basis in the copy command with a /v parameter. Okay, here's MS-DOS subdirectories. MS-DOS subdirectories is probably the principal reason why today's users should migrate towards MS-DOS. To the advent of large hard drives, we're using 10 meg drives today. I'm certain in the future that size will increase. We see signs of that happening everywhere in the industry. How do you possibly organize all these files? You can have hundreds and hundreds of files on a hard drive. Well, MS-DOS gives you this neat system of doing it, subdirectories, very much like the Unix operating system. First of all, there are a limited number of entries, 128 in a root directory. Actually, I think on some hard drives it will be 256, but it's limited. That's one problem. Well, MS-DOS will let you create subdirectories, and the subdirectories will appear to be like a separate default drive. And then you can organize your files, and we have some typical organization. For example, we have a hard drive, and instead of having hundreds of files, there'll be the root directory. Well, the root directory can be 3 subdirectories: bin, dev, and users. Under bin, we can put all the system files. Under dev, we could put all the device files. And under users, we could have my files, Bruce's files, and Wayne's files. And we could separate them quite neatly, all on the same drive, without using additional partition letters, and without confusing all our files. You can imagine the mishmash if the 3 of us were developing software and we all try to put it all in one directory. Well, that's what used to happen in the old days of CPM. Here are the commands to control subdirectories. mkdir, which can be abbreviated MD, creates a subdirectory. It's just a single name. It doesn't need any extension at all. So, for example, to create the subdirectory user, we do md/user, and that will create user as a child of the root directory. Then we can create subdirectory Joe as a child of user. We can also change the current default subdirectory. And when you're in a default subdirectory, all you will see is the files in that subdirectory. And file commands to the command processor will treat the default subdirectory in a very similar manner to the way they used to treat the default drive in CPM. And you can see there's change directory. There are some special characters for change directory that make it a little easier to access files. Because as you can imagine, you can grow quite a complex tree of subdirectories on a big hard drive. And there's one example, chdir ... automatically moves up one directory level. Of course, if you're already at the root, it won't do anything. And that's rm or rmdir for remove dir. It removes the subdirectory. No subdirectory will be deleted under any circumstances unless you explicitly use that command. So if you're in a subdirectory and there's another subdirectory and there's a list of files and you do a delete ***, it will delete all the regular files, but the subdirectory will be untouched. The only way you can remove a subdirectory is if the directory is empty. The operating system will tell you that it can't remove it. Specifying a path requires special syntax. A / prefixes path directory name. A / alone specifies the root directory. A period means start at the current directory. 2 periods mean start at the parent directory. Now, when we talk of 2 periods, we always mean the parent of the current subdirectory you're in. Okay, here's some examples. Assuming a path has been established with change directory users u. So now we're in the subdirectory users u. If we do a plain directory, we'll see the files in subdirectory u, which is the current default subdirectory. If we do a dir ... we go up to the parent of u, which is users, and we'll see all the files and users. If we do dir ... \save, we'll see all the files in a sister directory that's also hung off of users called save. You might call them parallel directories, or, as they say in the slide, sister directories. Then dir \archive will list files in uarchive, because archive is a child directory of our current default subdirectory. And dir \ alone will list the files in the root directory. It seems a little confusing, but I guarantee if you sit down at an MS-DOS machine and run through some of these commands and some of these exercises, you'll rapidly understand this type of organization. For example, there's a system upstairs that I put some public domain software on, so I made one subdirectory called Marshall. That's me. So everyone will know, oh, all these files came from me. Then under Marshall, you go into that subdirectory, you'll see comms for communication programs, DOS tips for DOS tips, and AIM86 for the AIM86 CPM emulator. So I have my name right away. You see it staring at you as a subdirectory. You go in there and you avoid looking at all the other files that are on the disk, and you know where they all came from. So it's very powerful. It's a good way of organizing. Okay, here's a little bit of the differences. There are actually more than these slides even tell, because MS-DOS has within it the hooks for such things as limited multitasking, and also it has the hooks in it to do networking. To do true networking, file sharing, and file redirection. MS-DOS does not use the Z80. It only uses the Z80 for disk processing. Okay, that slide is pretty clear. CP/M uses a vastly different file structure than MS-DOS. That's very true. And as a result, MS-DOS on a hard drive will be somewhat faster. The blocking, deblocking algorithms are very different. And also under MS-DOS, the current versions of MS-DOS, the file system can be treated very much in a Unix-like way, which is much easier for a program where a file is treated as a contiguous series of bytes. And all you have to do to read a file in MS-DOS 2.0 and above is tell the operating system to return a handle for a string, which is the file's name. The operating system returns a handle. Then you set a pointer to a point within the file, and then you read X number of bytes. There's no logical record lengths. There are no file control blocks. In fact, the use of file control blocks, which is a CP/M construct, is strongly discouraged. It's an impediment to networking, and in fact, in networking MS-DOS, they've had to simulate file control blocks, and so it's a rather clumsy way of doing things. Okay, here's a comparison of MS-DOS and PC-DOS. Well, obviously the hardware is radically different on the Rainbow, quite a bit different. There are also some functional differences. In memory mapping, PC-DOS begins at paragraph 60. Rainbow MS-DOS begins at paragraph 40. That difference is due to IBM locates their BIOS data area between 20 and 40. In our MS-DOS, in digital MS-DOS, the escape sequence parser, the VT102 parser, is always available. In IBM PC-DOS, you have to install your escape sequence parser. Also, our keyboard will generate escape sequences right from MS-DOS. You do not have that capability in IBM PC-DOS unless you buy a special product that will do it for you. PC-DOS is a very crude comms driver, and extremely crude. Our MS-DOS has a very advanced, fully buffered, interrupt-driven comms driver available for you. And that's it. That's a little overview of MS-DOS.
CP/M end of this discussion is going to be a little bit different. We'll run over quickly the basic differences between CP/M 8086 and CP/M 86 and the differences between version 1 and version 2. While Marshall was currently cutting CP/M, Wayne and myself decided we'd let people have our office numbers and home number, but we have to get our cards made because you'll notice they'll both contain the same number. They're actually Marshall's home number and office number. We don't get mad, we get even. CP/M 80 reserves the first 256 bytes of RAM for system use. The CCP section below describes the base page area. CP/M 86 also reserves the base page for each transient program loaded. You'll see the three parts of CP/M, the CCP, BIOS, and BDOS, and below them each the functions that they utilize. The console command processor accepts, interprets, and executes commands, recognizes and executes built-in commands such as dir, dir-s. Basic disk operating system, BDOS, performs all logical I/O and disk operations, either in response by the CCP or built-in commands or a user transient program. And as you'll notice the notes below, it does all operations in a hardware-dependent manner. The BDOS contains a number of useful functions that provide disk and other I/O operations to programs through a standardized access method. Basic I/O input-output system, the BIOS, which contains the standard routines that control the actual hardware of the computer system, including these routines to display a character on the logical console device, send a character to the logical printing device, and read and write a record to the disk. Access BIOS routines to perform all physical I/O. This is a list as the following of the differences between the 100B and 100 plus ROMs. which are not available in the 100A. The bell character now does not cause a hesitation the first time that it beeps, but hesitates only for subsequent bell characters that occur too close together. New setup parameters permit a choice of either caps lock or shift block mode for the lock key. Every ROM set supports all keyboard variations. At startup, the firmware asks you to select a keyboard if the stored setup parameters indicate that none had previously been selected. The non-volatile memory then stores the choice. If you'll notice, the first time that you fire up your Rainbow, it'll ask you that. It'll come up with a graphics type screen, and it'll ask you which language that you wish your keyboard to be in. And then there's a new setup parameter to allow you to invoke a national replacement character set for the country-specific use. The compose algorithm now works. The printer port's DTR line is monitored when in terminal mode. If it is not asserting, printing does not occur. And pressing Control 2 through Control 8 keys generate the proper control sequence codes now. Control symbol keys are no longer shift dependent. The escape sequences for erase, inline, and display now accept multiple selective parameters instead of ignoring all after the first parameter. And all the setup and all the error messages are displayed in the language that you've chosen for the keyboard. Single Shift 2 and Shift 3 escape sequences apply only to the next following graphic character and are not canceled by an intervening escape sequence or other non-graphic character. The print screen key generates an escape left bracket 1, 2, and what do you call that, Wayne? Yeah, I pronounce it wrong. Tilde. In console mode. Control XX keys auto-repeat. Setup automatically determines the amount of the installed RAM and displays it. In the A, when you press in the setup mode and you check the RAM area, that actually was just what you set and not actually what the machine had. This now checks the machine and displays what you actually have. These are the BDOS functions that are now in 2.2 and in 1. You'll notice the last 10 are only available to CPM86. The rest of them are available to CPM80. These slides with the different BDOS and BIOS codes are available in the new 2.0 CPM Tech Doc Kit. It's just come out. Sector blocking and deblocking. BDOS performs all disk read and write functions in units of logical records. These logical records contain 128 bytes and correspond to the length of one physical sector on an original 8-inch single-sided, single-density diskettes in the old S100 days. These diskettes often utilize physical sectors larger than 128 bytes. Therefore, the CPM BIOS contains routines to combine more than one logical sector or record into one physical record and to perform the reverse operation when reading it. The Rainbow computer's BIOS contains such routines since it uses a 512-byte sector. File control blocks. A disk file function requires a 36-byte area of RAM called a file control block, FCBs. The application program initially sets up the FCB with the disk drive, the file name, and the file type. All other bytes are set to 0. The program places the address of each file's FCB into the DX before invoking a BIOS disk function. The CCP sets up the default FCBs in the base page using the information in the command tail at the end of the program when it was loaded. Big thing on this is to make sure that you move the second FCB out of the area. So when you overwrite, you move the first one out when the second one comes in, because you will overwrite it in your program. The main thing to look for on this page is in the 33rd position of the FCB, the 1-byte field used to store the number of the current logical record to be read or written in a sequential file operation. After every read or write operation, this field is incremented by the BDOS. It must be initialized to 0 by the application program when the FCB is set up, otherwise you'll clobber it. In CCPM 8680, the cold and warm start function reinitializes communication and printer port chips to the default state. Any program that you write that expects or specs to drive these ports must have set this up. And again, the last four are only in CPM 86. Functions 47 and 49 are described in the CPM 86 Operating Systems Release 1.1 release notes, not in the Operating System Systems Guide. Generally, the BDOS functions are invoked as follows. Z80 on the Z80 side, function number in C, arguments in E, pointer to the FCB in D and E, and then you'd call 0005. In 8088, you put the function number in CL, the arguments in DL, DX points to the FCB, and then the function call is interrupt 224. On the exit, the Z80, the byte values are in A, other values in HL. In the 8088, AL contains the byte values, and BX contains the other values. Special considerations. BDOS does not save any of the CPU registers when performing the call functions. This means your program must save the register contents before calling the function. And in many cases, CPM 86 function is slightly different from the same function in CPM 80. This will result in programs not running quite correctly, or out and out failing. CPM 8680 version 1.0 contains 3 special systems files, if you'll notice on your disk, if you've been hunting around. We had a z80ccp.syst, a z80.syst, and a primitive private.syst. CPM version 2, we combine these into one file called z80cnf.syst. That's why if you've looked at your 2 different versions, if you have them, you think some files are missing. They aren't. They're all combined. The I.O. byte, the name of a special 1-byte location in memory, is also a CPM function that uses the I.O. byte contents. Its purpose is to allow each of the 4 logical I.O. devices to be assigned to any of the 4 possible physical devices. Whenever one of the logical devices is called for status, input, or output, the BIOS accesses the physical device that is currently assigned to it by the I.O. byte. You can change the I.O. byte assignments by using the stat utility. Application programs can change these assignments using BIOS function 8 in CPM 80, the function 8 period. In CPM 80, the I.O. byte is stored at location 03 hex in the base page and may be read or changed at that location. In CPM 86, the I.O. byte may be anywhere in the BIOS and is accessed by the get IOB and set IOB functions. Difference on version 2, the BAT function input to the paper tape reader, physical communications port, instead of the logical device, RDR, and BAT output is to paper tape punch. This is different from the normal assignment. Because of this, there may be old CPM programs that expect the standard assignments. They cannot run under version 2.0. This one we thought people might be interested in because I'm sure there's a few that have run into it. The correct procedure for temporarily disabling the interrupts off circuitry is as follows. The one thing that's not on here, when you do the CLI disable interrupts, your clock will be suspended at the state that it was at. You have 100 milliseconds to service your interrupts. If you were at 95 milliseconds when you suspend the clock, when you come back in after enabling the interrupts with the STI, you've got 5 milliseconds to then service that interrupt. The clock resumes where it was stopped. This is a summary of the extended console transfer types and function codes. We added a new extended console function, which Wayne is going to go into. Functions 0 through 2 are reserved. 3 is a 16-bit key code for keyboard. 4 is ROM and BIOS version numbers. Clear screen. 5 is clear screen and home cursor. 6, put cursor at specified location. 7, return cursor positioning. 8, disable cursor. 9, enable cursor. And one thing to watch when you enable and disable cursor is if your program happens to go through a loop and disables a cursor 3 or 4 times, you best enable it 3 or 4 times because it keeps a count, and it won't enable it back until you enable it as many times as you disabled it. So sometimes if you lose your cursor and wonder why, do a debug routine and check how many times you disabled it, and then see if you enabled it enough times. 10 is character data transferred to display, limited to one line. This is the complement of function 20. 11, character attributes transferred to display, limited to one line, and this is also the complement of function 21. 12, line attributes and overall screen attributes transferred to display. This is the complement of function 22. 13 through 15 are reserved. 16, ring the keyboard bell. 17 to 19 reserved. 20, character data transferred from display, and this is the complement of 1. 21, character attributes transferred from display. This is the complement of 11. 22 is line attributes and overall screen attributes transferred from display, and this is the complement of function 12. Now Wayne will go into how to program the extended console.
I apologize if we're going so fast. We'd like to leave a little bit of time for you to ask questions. You can always catch us at the technical Q&A tomorrow afternoon or up in the PC6 suite tonight if you really want to get some more detail on this. Just a quick for the trivia buffs. The reason for the extended console, the extended BIOS commands, of which extended console is one part of it, was for support of ISVs and the DEC utilities. And it was originally written as a subroutine library, which is available. I think Marshall put it up on the system upstairs. If not, he has it with him here. You can get a copy of the sources for that. That's only needed if you want something that will run under version 1 of the operating system as well. It's also needed if you want to try and do these same things under MS-DOS. It was initially, like I say, a subroutine library, and it is available. It got built into the operating system at the version 2 level. It was too late for version 1. Okay, all extended BIOS commands use the VDOS function 50, which is a direct BIOS access technique that CPM has defined. You load the CL register with a 50 decimal value. You make the DS-DX combination point to what's called a BIOS descriptor block, and then you execute the interrupt 224 to invoke the VDOS. Structure of that BIOS descriptor block is 5 bytes. The first byte, you specify which BIOS function you want, and the second 2 words following that are what is going to be passed to that BIOS function in the CX and the DX registers respectively. This is the defined interface between VDOS and the BIOS in CPM86. All you do is essentially index into a jump table with some values in the CX and DX, and it's interpreted in the context of whatever function you're using. For the extended console functions, that BIOS function number is an 80 hex. The words following it are the offset and segment to make up an address pointer to the extended console function block, which is where all the extended BIOS commands get their information from. The extended console function block always starts off with the first word. This is all word related. Every entry in this is a word. The extended console function number. And then based on what that number is, different things will happen. If that function is 5, we'll do a clear the screen and home the cursor. What that means is that all the lines on the screen will be restored to their normal height and width, single heights and single width. All characters will be set to the null character with no attributes on, and the cursor will be placed at the upper left-hand corner of the screen. 8 and 9 are the complements for disable and enable the cursor, and as Bruce indicated, you have to watch out. It counts how many times you disable and how many times you enable. If you don't enable enough, it won't show up. If you enable too much, you may have a cursor ghost lying around on the screen. 16 was put in there because there was no way to ring the keyboard bell except to go through the normal console out path with the Control-G character. And once you go through the normal console out path, CPM does some things to you. It goes out and sometimes just checks and steals away characters that you can't get at. So to get away from that problem, the function 16 was added, which allows you to ring the keyboard bell within this same extended console overall structure. We're going to continually make these a little bit more complicated. You know, so we're going to add a little bit each time. Function 3 allows you to get at 16-bit key codes. If you've been bothered with trying to parse escape strings coming off the console normal path with escape, left square bracket, whatever, tilde, whatever, and you don't want to bother with that, or you'd like to get a little bit more detail, like you'd like to be able to see a shifted left and right arrow or a controlled right and left arrow or combinations thereof, this allows you to get at that information. The return status indicates 3 different possibilities. -1 says there's a character available, its code is in the next word. 0 means that there's no character available. And 1 is a special variation. When you're first getting this thing started, there's a potential for something to be in what's called the 8-bit buffer, the normal console path. And you have to empty that out first. So you want to go out, do a status on is there a key available, and do that and empty it until there is nothing available. Don't go out and ask for one just indiscriminately, because CPM says, I'm not going to return to you until I've got one. So when it's empty, it'll never come back to you. So you have to do the status check first. Key codes, if the high byte is 0, then the low byte contains the ASCII code with all the control and shift character states all taken into account. If the high byte is not equal to 0, bit 8 is used to indicate that this is a function key. A function key is something outside the normal typing array. It includes the auxiliary keypad over on the far right. It includes what's called the editing keypad with the arrow keys, as well as all the keys across the top, what you would normally consider to be the function keys. Bits 9, 10, and 11 are state bits. They indicate whether or not shift, control, or lock states are currently in effect. And the low byte identifies the function key code. If anybody is comparing that against what you would get out of the normal ROM BIOS, or the ROM call itself, you'll find that they're different. They've been remapped to something nice without any holes in them. 0 is composed. You can only get that in a 100A because it's trapped out and it does something in a 100B. 1 through 20 are those function keys, 1 through 20, with the exception of 1, which is whole screen, 3, which is setup, and 11 through 13, which translate into ASCII codes for line feed, backspace, and escape. 21 through 30 are your editing keys, left to right and top to bottom. 31 through 40 are the auxiliary keypads 0 through 9. 41 through 43 are the auxiliary keypad comma, dash, and period. 44 to 47 are the auxiliary keypads PF1 through 4. And 48 is the auxiliary keypad enter key. Function 4, if you're release level dependent, you want to know what ROM level or BIOS version level you have, this will allow it to be returned to you. It comes back as a 14-byte ASCII string with null separators. It'll give you a number software version, the similar for the hardware version, and then it'll also give you the language information. So if you've got a program that's language dependent, we want to know whether or not you're running in French Canadian or in German or Italian or whatever, this will tell you. 15 different variations for the language, by the way. Cursor positioning. Rather than go through the escape sequence, either sending or receiving, to figure out where or how to set the cursor position, this will allow you to set it to lines 1 through 24, columns 1 through 132. If the argument that you enter is 0, then we ignore that particular one, so it allows you to leave it in a particular line or column while changing the other, and it limits to the maximum values. If you give it a 25 or above in the line number, for instance, it will clamp it to 24. Similarly for the columns, and it knows whether or not the line is double wide or 132 base width or whatever. It all takes it all into account. This is a rather complex one to explain, but I'll do my best real quick here. This allows you to save and restore what we call a screen context. In other words, the overall characteristics of the screen. whether the background is dark or light, whether the width is base 80 or 132 columns, and what the different individual line attributes are. This is used for people that want to do windowing type applications where they don't want to destroy the original context that's there so that they can replace it later. The only thing you have to watch out for is between the time that you save this context and the time that you restore it, don't scroll the screen. Everything will screw up. So you have to treat the screen as a window and write to it directly. Don't cause it to scroll by writing a line feed when you're down on the bottom. Okay? The screen background or the screen width can be individually ignored when you restore by setting the value to 0 instead of the values that are shown there. The line attributes, bit 0, if it's set, it indicates that this line is part of the scrolling region. That doesn't mean that you can use that to control it. It's just, it's there as an artifact of the way things work, and only means something to the hardware when you're doing a smooth scrolling. There's lots of other conditions that have to be maintained in order to guarantee that it's part of the scrolling region. So don't use that to try and control a scrolling region window. Bits 2 and 1 are a 2-bit field that indicate whether this is the bottom or the top of a double high character, a double wide line, or a normal line. Now we get into the good stuff. Transferring character data. The second 2 words there form a pointer to a byte array of characters that you have to set up within your application, whatever you want. The next one is a mode, and the mode means different things depending on whether you're transferring to the display or from the display. When you're transferring to the display, you have an option using mode to erase to the end of the line or not erase to the end of the line. So that saves you an extra step if that's the kind of thing that you're doing. When transferring from the display, it indicates whether or not there should be a character set taken into account in the process of returning it. When the next one is the line numbers and the column number at which the transfer begins, and it's limited to 1 line again. The number of characters that you want to transfer, and that will truncate if you try to go farther than the line would normally allow you. Character set for transferring to the display, you can specify none, which is normally used when you're just doing a fast save and restore, which means it's just a raw dump back and forth. Or you can specify that all the transfers in this particular transfer, all the character codes in this particular transfer are US ASCII related. They're either UK or the VT100 line drawing, because the VT100 line drawing set overlays the lowercase characters, so you have to take that into account. On a transfer from the display, if the mode is such that you want to return the character set information, then that is the offset of a parallel set of character set array information that tells you for each character that you transferred what character set it belongs to. Any 8-bit characters will be interpreted as belonging to US ASCII. And finally, all the characters in this particular transfer will be using this one character attribute. So if you want to change attributes, you got to play another game. But it gives you the ability to have reverse video, bold, blink, underscore, or any combination thereof in your character attributes for that display. And that has no meaning when you're doing the transfer from the display. And finally, as I said before, if you want to change the character attributes, and you have to play a little different game, I listed a little different game here, this allows you to transfer the character attributes to and from the screen. Again, the format is very similar. The first 2 words following the function number are a pointer to an array of attributes. Mode doesn't mean anything in this case, so it's not used. Line number, column number, same thing. Number of transfer is the same thing. And the character attributes are, again, exactly the same. Give an idea of what kind of performance you can get if you've watched the Mink program under CPM 8680. It uses this functionality. If you watch Do It, if anybody has seen Do It run, it uses that. And if you're just doing character transfer data you can update an entire screen in about 90 milliseconds. Okay. You got time for questions? Yeah, let's start.
Bill Rich, Scientific Atlanta. I have a question on the MS-DOS section. I think you had a mistake on one of your slides when you said if you did a dir /archive, you would get a directory of the subdirectory archive of whatever you happen to be your current directory. And as far as I can tell, that gives you a directory of your of the archive off the root directory only.
Correct.
Well, on your slide it said...
No.
Oh, okay, I didn't know.
Thanks, Luca. There were some other minor errors there, too.
Yeah, that was major.
That was major. True.
Is there documented the MS-DOS equivalent of direct console programming?
The best thing you can do is at the PC SIG suite, if you look under Drive E subdirectory Marshall, there's a subdirectory AIM86. That contains the source code for XCON, which is a linkable version of the extended console, and TextCon, which is a stay resident version. It has all the functionality, the stay resident version has all the functionality of the CPM extended console.
I ask this because somebody tried to put that functionality into the MS-DOS Kermit to save the previous screen, and apparently they were using undocumented pointers that they just happened to find, and I discovered double width screws it up. Is there any way you could get that information you just mentioned onto the market system lcg.kermit?
It may be there. I don't check into the market system very often, but I can put it on the FidoNet that Bruce runs, which is at area code 617-486-2285.
What was your subdirectory Marshall / what?
Marshall/AIM86.
It's AME86.
Where did those documents begin?
Excuse me?
All those the extended console.
Programmer reference manual.
Program, the version 2.0 of the Programmer's Reference Manual. It's just come out in the Tech Doc Kit. And it has a full chapter, a fairly large chapter on all the extended
Bob Manfredi, University of Connecticut. Do you take wish list items here? They're very brief.
Probably a Q&A.
Q&A would be a better format for that.
Okay.
Ken Horton Harris Corporation. Had a question on MS-DOS. Is there any quick way to rename a file, changing it from the subdirectory that it's currently in?
You can rename a file.
But it has to be in the same directory, as far as I know, or the same subdirectory.
I believe you can specify a path on it.
No.
Will not work.
Okay, then the audience provides the answer.
Somebody had told me that there was some way of messing with the FAT block on PC-DOS, but
There's a way documented in like 2 months ago PC Tech Journal that seems to work for the Rainbow. I ran it on my Rainbow, it worked fine. And it's about, it's either, it's in PC Tech Journal either from last month or the month before last, on how to do it, they call it a super rename.
thank you.
Thank you.
Move also.
Just a reminder, the PC suite will be open, that's room 2206, and it will be open from 5 to 8 tonight.
This is the end of this cassette. Please advance the tape as far as possible for the next playing.